Debbie, in this session we're going to investigate the subtraction of mixed numerals where we have unrelated denominators. So tell me about this context.
Here we have a recipe for fruit aid, and as you can see we have 3 different types of juice and some soda water. What we're going to look at is subtraction as comparison, and we're going to focus on the apple juice and the pineapple juice. And so my question to you would be, we notice that the pineapple juice, there's more in the recipe, but the question is how much more?
How much more?
Right.
Sure.
So to represent that symbolically, we would have the larger amount compared to, in this case, the subtraction sign is used for compared to, the 1 2/3.
Right.
And you'll notice that the denominators are unrelated.
Totally
as well.
unrelated.
Right. We're going to look at 2 students' work or strategies for finding the difference or comparing the 2 amounts.
Okay.
We have Daniel and Isabelle. What do you notice about their strategies?
Daniel has dealt with these mixed numerals. He's now decided to change them and use improper fractions.
He is.
There's something he has to do before he does the calculation. That's his first step.
Right.
Isabelle is dealing with them, or just treating them still as mixed numerals. It looks like she's going to subtract whole numbers before she deals with the fractional part.
Okay. We're going to look at one at a time. We're going to start with Daniel.
Okay.
Here we have Daniel's work. What is he going to have to do first before he can subtract or find the difference?
Need to find a common denominator. 12 seems to make sense, so he's going to convert these to twelfths.
Right.
11 fourths as twelfths will be 33 twelfths, a rather large, messy fraction.
Right.
And he's going to subtract 5/3 as twelfths, which is going to give me 20 twelfths.
Good. So at this point we have a common denominator, which means that we have the same size part for each of the 2 fractions. Because they're unrelated, we had to find equivalent fractions for both of them. We have 33 twelfths and 20 twelfths. What are you going to do with that?
The difference between these two is 13 twelfths.
So at this point, Daniel might stop and think that he's done with the answer, but we always have to make sure that we go back to the context. And the context was around whole cups. It doesn't make sense that the answer tells us how many twelfths of a cup we have. So what would Daniel have to do in
Well,
the
12
end?
twelfths will make one whole, and I've got 13 of them, so I have 1 whole, and I have 1/12 remaining.
So we have 1 and 1/12 cups greater than.
Well, yeah, difference.
Difference.
Sure.
Right.
Let's now take a look at how Isabelle calculated using the mixed numerals.
Okay.
Right, so the way she's written that, I'm assuming that she probably calculated the whole numbers first as 1.
Right.
Then 3/4 need to be expressed as twelfths.
Right.
So 3/4 as twelfths is 9 twelfths.
Good.
And then she's going to have to subtract 2/3.
Right.
But as twelfths, 2/3 is 8 twelfths.
So once again, she was working with the mixed numbers. She decided to work with the whole parts first and then the fractional amounts. Once again, because they're unrelated denominators, both of those fractions had to be renamed.
Right, so now I'm left with 1/12. So I guess if I had to write this as the answer 2 3/4 subtract 1 2/3 is 1 and 1/12.
Good.
Right?
That's right. Next, I want us to look at one more student, and I want to compare Zoe's work with Isabelle's work.
Okay, let's look at that.
Okay. Let's look at Zoe's work, and she noticed that she had an error. Why might she have had an error?
Well, I can see here when you compare 2 numbers and you're finding the difference between 2, the larger one, the greater one becomes the total.
Correct.
And then you subtract the other one. Right? And the way she's expressed this here is she's starting with 2, which is only actually part of the total.
That's right.
Right? There's another part to the total, there's 3/4. And she subtract 1,
Right.
which is part of this fraction. Then she subtracted actually part of the total. And then she subtracted the other fractional part of the other fraction, the other one over here.
Right.
So she's subtracting far too
Everything
much.
from 2. Right.
That's right. So that will definitely give her the wrong answer.
Sometimes what happens is that you might have someone like Isabelle and Zoe who mentally do the same thing, but the recording of it is different. So in this case, we have working with the wholes then the parts. Isabelle recorded it correctly.
Mm-hmm.
Perhaps Zoe did it correctly, but her recording of the symbolic process was not
Right.
done correctly.
Yeah, but just be very aware as a teacher, if a child writes it like that, it could easily lend itself to an error.
That's right. Would be better to write it in two lines.
Express it another way.
Right.
That's right. With this example, Debbie, we actually have 3/4, and we can subtract 2/3 from 3/4. We don't have to decompose a whole to assist us.
That's right.
So now we need to look at an example where there's some kind of decomposition happening.
Okay, we'll do that next.
Right.
Here we have the same recipe that we had before for fruit aid. This time, however, what we're going to do is we're going to compare the amounts of pineapple juice and cranberry juice. So we're going to represent it symbolically this way. You'll notice that the 3/4 is indeed greater than the 1/3, so there's going to have to be some decomposition.
So I can see there's more cranberry juice, so it becomes a total. We're going to have to find the difference between this number and that number, and we could do that by subtracting the smaller amount.
Right. So what we're going to do is we're going to once again look at a couple of different students' work and consider different ways that they worked out the difference.
Okay.
We have Kenji and Emma.
Right. Kenji's dealing with the mixed numerals.
He is.
And unlike Zoe in the previous example, he's stuck with the total and he's subtracting parts
He did.
of the
right.
other.
Right.
And Emma's dealing with improper fractions.
Good. What we'll do is we'll consider Kenji's work and how he would have to work to find the difference. All right. How can Kenji kind of work out the rest of the difference?
I suspect he subtracted the 2 first of all, the 2 wholes. So starting with 3 and 1/3, subtracting 2, you're left with 1 and 1/3. And then we need to subtract the 3/4 or 3/4.
Okay, so once again, he's subtracting in parts.
Mm-hmm.
First the whole number amount, and then now he has to deal with the fractional amount. What's he going to have to do next?
Need to change these. I can't subtract fourths from thirds, so I need to make this 12ths, I guess.
So not only do you have to work with a common denominator, but you'll notice that eventually we're going to have to deal with a decomposition.
Sure.
But let's change the denominators first.
Okay, so I'm still going to have 1, and 1/3 expressed in 12ths is 4/12.
Good.
And 3/4 or 3/4 expressed in 12ths is 9/12.
Right. Now we'll see that we really have a challenge here. Subtracting 9/12 from 4/12, there's a problem.
Yeah.
This is where the decomposition occurs.
Right.
What could you do?
Well, the easiest way is just to make this into an improper fraction.
Yes. Mhm.
Right, so I have 4/12 here, but I also already have 12/12 over here.
Right.
So 12/12 plus the 4/12 is a total of 16/12,
Good.
and then I can subtract
Now you can.
9/12.
So what would be the difference in this case?
7/12.
7/12. So we have 7/12 more cups of cranberry juice.
Correct.
Right.
Let's have a quick look at what Emma did.
Okay, let's do that. Here we have Emma's work, and what she decided to do was to convert the mixed numbers into improper fractions. What's interesting is that what that means is that she's already done the decomposition on the front end.
Right.
Let's take a look at what happens after this.
So she'll need to convert these to 12ths, I guess.
Right.
So using my understanding of equivalent fractions, 10/3 expressed as 12ths is 40/12ths.
Mm-hmm.
And 11/4 expressed as 12ths is 33. So rather large numerators.
Correct. So the decomposition has already been done for us. Because it's unrelated denominators, we had to rename both of them. Right. But we're now in a position to just very easily find
Do the subtraction or
difference.
find the difference.
Right, right.
So with the difference between 40 as a numerator and 33 is 7.
Correct.
So I guess if I take the original equation, the difference is 7/12.
Right. To sum up, we were looking at several different strategies, so it's important to recognize that when finding the differences or subtracting mixed numbers, that sometimes students can work with the mixed numbers, often involving subtracting in parts in different ways. We have to be careful, however, how they record that and that it truly reflects how they're thinking about it or how they should be thinking about that. But they could also be working with improper fractions. When decomposition is part of that, when they do the conversion to the improper fractions, it's already done on the front end.
Terrific, thank you.
Yeah, you're welcome.